Hello and welcome to MCAT Chat. Today we are going to be chatting about sensory processing. So the first item that we need to talk about is sensation. And with sensation, just know that it all begins with a stimulus. And what's a stimulus? A stimulus is basically any input that can be detected by you, the organism, in the environment. And this whole idea of sensory processing is really along the lines of the study of psychophysics. So psychophysics is pretty important in sensory processing because it's the study of how physical stimulus is converted or it's translated or how it's understood as a psychological experience. So how is physical stimulus understood as a psychological experience? That's what psychophysics is trying to understand. So the idea of the threshold is a concept that's really central to psychophysics. The threshold is like the dividing point. It's the make it or break it point between energy levels that are either going to have or they're not going to have a detectable effect. And so along those lines, the absolute threshold, you can think about that as the absolute minimum. It is the minimum amount of stimulation that an organism can pick up on. And then also along these lines is the just noticeable difference. That's something that's also highly related to these topics. And the just noticeable difference is basically the smallest difference. It is the smallest, the tiniest amount of difference in the stimulation that a specific sense can pick up on or can detect. So if I start to talk lower and I decrease my volume, what decibel, at what point did you realize, what was the smallest difference that you realized that there was a change in volume in my voice? So that's what the just noticeable difference is. And then Weber's law is basically just trying to quantify that. Weber's law states that the magnitude or the size of the just noticeable difference is a constant, and that constant is proportional to the original stimulus. Okay. The next item on the agenda is the sensory detection theory. What is the sensory detection theory? Well, the sensory detection theory is just postulating that detecting a stimulus involves two processes. It involves a decision process as well as a sensory process. So that means that both of these processes are influenced and they are affected by many factors other than the stimulus intensity. So essentially what this is saying is that you are setting the criterion, sorry, I said that really weird, for how you want to pick up on certain stimuli. So it's not just a sensory process. It's not that you perceive a stimulus once you experience it. There's also a decision process that's involved, and both of these can be affected and influenced by many other factors that are not just involved in the stimulus intensity. So the theory basically just attempts to account for the effects of decision making on stimulus detection. The sensory adaptation theory. Sensory adaptation is just when prolonged stimulation is going to lead to this gradual decline or a decrease in the sensitivity to that stimulus. So the example here that I'm going to give is the stinky public washroom. So let's say you're out and you don't want to, but you're just forced, you're put in that situation where you have to use a public washroom, which is okay. We've all been there. And the stench, it just hits you. It's like air has not hit this place in 7 years. Horrible. It smells awful. You don't want to breathe this air. If things can get any worse, there's a line and you have to stand in the line in this horrible smelling washroom. As you're washing your hands, you just kind of realize that it doesn't smell as bad as when you first came in. And it's not that the smell changed, it's just that you've kind of grown used to it. You've become adapted and you're not so in tuned to the constants in the environment. So it's an automatic process. It's not that you are telling yourself, okay, become adapted to this scent now. It's just that it's an unconscious process, and it just makes you more aware of differences or changes in your environment than something that's constant. So if someone else went to the washroom, smelled horrible, you might pick up on that new smell, but the constants of that stinky washroom is pretty much bearable by the end because you've become adapted to it. It's my little example. I don't know if that's going to stick for you or not, but I thought it was pretty good. Okay, next we're going to move on to sensory receptors. So what are sensory pathways? Sensory pathways are just routes to the nervous system. So They are just different roads in your body, basically, that different signals are going to take. So stimuli are going to cause some kind of signal in the body that's going to travel down these pathways or these roads all the way up to the nervous system, or the central nervous system specifically, which is your spinal cord, and then the head honcho, the brain. So there are 4 commonalities, 4 generic traits of all of these sensory pathways. And the first is sensory reception. So sensory receptors or reception is basically just the detection of a stimulus by these sensory cells that act as sensory receptors. And sensory cells could be specialized neurons, they could be epithelial cells. It all depends on what sensory pathway we're talking about. But these are basically just going to pick up on that stimuli. And then transduction is like that second commonality. And transduction is the conversion of that physical stimuli, or the physical stimulus or the chemical stimulus, or stimuli, could be multiple, I don't know. And that's going to cause a change in the membrane potential of that sensory receptor, that sensory cell. And the change in the membrane potential that is involved with the membrane of a sensory receptor is known as a receptor potential. I'm not sure how important that is, but it's just a change in membrane potential. And these are graded potentials, and their magnitude and the amount of that graded potential is going to be really dependent on how strong that stimulus was. Which takes us to number 3, which is transmission. So once the stimulus, now we've picked up on the stimulus, we've converted it into a receptor potential or a change in membrane potential. That was all transduction, and the first step. Now we're going to number 3, which is initiating the transmission and transmitting that action potential, if it was strong enough to form an action potential, to the central nervous system. And then we go on to step number 4, which is perception. So perceiving color, smell, sound, all of that are functions that are formed in the brain. It's pretty trippy, but perception really does not, perception of these types of stimuli like color and smell and sound are all things that exist in the brain, not necessarily outside of it. So what is perceiving all of these stimuli? It's your brain. So that's why it's so important, these sensory pathways, to get this information to the brain so that you can pick up on it. Okay, now we're going to move on to types of sensory receptors. And there are 5 types that I'm pretty sure people have learned in high school, but you might have forgotten. So again, receptors, they could be neurons, they could be specialized cells, and then there's 5 categories of them. Okay, so they could be mechanoreceptors. So some of these are really intuitive. So mechanoreceptors, they're picking up on physical stimuli. So that could be pressure, it could be touch, it could be motion. It also could be sound. Those are all mechanoreceptors. That's because sound travels with kind of in pressure waves, and we'll talk about that. So that's why it fits into mechanoreceptor. The next is a chemoreceptor. So chemoreceptor is just information about solute concentration. It's just responding to different individual molecules or chemicals. Electromagnetic receptors, or electromagnetic rather, are going to be detecting electromagnetic energy. So this could be light, this could be electricity, it could be magnetism. And then there are thermoreceptors, which are picking up on temperature. Is it hot? Is it cold? Those are thermoreceptors. And then pain receptors, this is extreme pressure or extreme temperature, or it could also be certain chemicals. It's kind of a combination of all of them that can cause damage to tissue and thus instigate pain. And that is basically sensory processing in a nutshell. Bye-bye.